Okay, so our next topic here on dealing with parametric equations is the surface area. Oops. Right, and again, we're going to strictly be looking at rotation about the x-axis. So we're going to rotate some piece of curve here, and we want to focus on the area generated, right, the surface area, not the volume, which was a problem we solved in Math 1 and some problems we did earlier in the semester here, solving the volume, but here we're looking at the surface area. And if you recall from earlier in the semester, probably one of the first couple weeks, the surface area for rotation about the x-axis we define as AB 2 pi y ds, right, where this ds represented the arc length. All right, so with that, now we can use the arc length. We can just switch out the formula that we previously had when we had functions of x and use the parametric formula, and y we will think of in terms of t, right? Now here, I'll just change the notation of the variables just to make it a point that these alpha beta are in terms of t. X prime of t squared plus y prime of t squared dt. All right, so this will be our surface area formula. All right, so let's do an example. All right, let's say I want to find the exact area of the surface obtained by rotating x equals 3t minus t cubed, y equals 3t squared for 1 about the x-axis. Okay. All right, so here we just plug in our formula, right? So the surface area limits from 0 to 1, right? And we have 2 pi, and then my y, which is 3t squared, square root x prime. So x prime will be 3 minus 3t squared plus y prime, which is 6t squared dt. All right. So now let's start to simplify, see what how I'm going to be able to evaluate this integral. So I'll pull out here the constants. So my surface area from 0 to 1 is 6 pi 0 to 1 t squared, square root, we get 9 minus 18t squared plus 9t to the 4th, and then plus 36t squared dt. All right, okay, so let's start simplifying here. We can combine like terms here, so we get t squared square root. Let me rewrite this as 9t to the 4th plus 18t squared when I combine the like terms, plus 9 dt. All right, I can factor. Here we get 3t squared plus 3 squared. All right, so that worked out nicely here. Okay, so now I get rid of the root. I can distribute here. Okay. So this becomes so 3/5 t to the 5th plus 1 t cubed evaluated at 1 and 0. So this becomes 6 pi 3/5 plus 1, and then 0 is just 0. So that gives me here 5, 8, 48 pi over 5. Okay, so that's how we use the surface area formula to calculate surface area for our parametric equations.